complexities to scan anything. You need to, usually the scanners are very big, you need to carry laptop, setup. Okay. See, this is a very the latest 3D scanner launched by Shining 3D. I will explain about Shining 3D. This is a inbuilt processor, inbuilt display 3D scanner. So 3D scanner converts physical object into digital image. Okay. Physical object means what? It can be anything. This is a physical object, physical environment. People scan anything in this world nowadays. Those days people used to scan only for engineering applications. Last week I went to dental. They even scanned my teeth. Okay. So 3D scanning is now everywhere, every industry. Okay. So today I will be discussing about only limited to automotive applications. We offer a 3D scanner, printer, software to manufacturing companies capex investment. If you want to implement 3D scanning technologies in your company, we can help. Okay. So we have sold these scanners around 50 scanners in last 1 year itself, mainly for automotive companies. So we are a suppliers of 3D scanners and software printers. For the companies who want to assess the technology before investment, we also give them the 3D surveys of using the same equipments. Other than this sales and service, we are a pioneer in automotive digital benchmarking. Okay. Today, many automotive companies, Mahindra and Mahindra, a lot of companies, we have done the complete vehicle teardown and to sell scanners and softwares and printers, we have a collaboration with the global OEMs. Okay. Shining 3D is one of the global OEMs. They make a 3D scanners. They are there in the market. They are there in the market from some time. It's not a typical Chinese company. They are a very big company in Chinese. They make 180 million USD in 2024. They have two different types of vertical. 3D scanners for manufacturing, 3D scanner for healthcare. They make different types of a 3D scanner for manufacturing companies. We are a master reseller for Shining 3D in India. Shining 3D, Hexagon Geomagic Software, and True Pro and Exact Flat. There are 4 companies we have collaboration with to bundle with the 3D scanners. Before we talk about the 3D scanner, it solves the problem of measuring. Okay. Without 3D scanner, imagine you have some part, you want to create the CAD model. What do? You use a conventional equipment, you measure, because you need the measurement to design anything. Talk about simple measurements like vernier caliper, CMM issue. They are conventional equipments. You touch the part, you measure, you design. Okay. So with the 3D scanner, it's a complete non-contact methodology. Okay. If you ask me what is the best 3D scanner in this world, there's no answer. Best 3D scanner is based on what is the part you want to scan, what is the size, what is the accuracy. There are different types of technology. The simplest way, the scanner converts physical object into digital image. Okay. There are different types of technology. Laser technology, structural light technology, and dynamic tracking technology. Okay. In laser technology, the scanner emits laser light into the physical object. Where light reflects, there is a camera inside the scanner that converts the reflection into 3D image. That is how laser works. This is exactly the laser scanner I have brought, the handheld laser scanner. And the another scanner called structural light, where the scanner projects the fringe pattern light into the object, where the shape, the change happens. When the light falls onto the object, the shape changes, right? The change is captured using the camera. The camera captures the shape. It takes a shot by shot. Structural light technology. And we also have a dynamic tracking technology which we have brought here. Say there is a tracker unit, there is a scanner unit. The first 2 systems, you may need to put some marker to scan. But third system, you may not need a sticker itself completely. There is a tracker, there is a scanner. Tracker tracks the movement of the scanner, and with this range, you can scan anything without applying the marker on the part. People use LiDAR technology to scan the entire plant, buildings, and people use arm-based laser technologies where the movement is arrested to the. I think you might have used this laser arm technologies. That's quite old. Okay, but this is the very latest technologies. Okay. Now, in Shining 3D, they have got a metrology grade 3D scanner, like handheld scanners, optical tracker scanners, and 3D structural light scanner, and robotic system. All the 3 different types of scanners can be integrated into robotic system for inline measurements, inline scanning. So this is how the laser handheld scanner works. You just hold the scanner in hand, and where the light reflects, there's a computer there. The computer can visualize what it scans. And this is a structural light scanner. Well, it's a tripod setup. You just put the part on the rotatable turns, and the scanner keeps capturing the object shot by shot. And this is the tracker based scanner. You see, we are not pasting any marker on the object, directly they scan. And like I said, this is an automated system. Any kind of a 3D scanner can be integrated into the robot and we can use it for a measurement. This is how the scanner works. Just if you have not seen the scanner, I thought I would just give you a little glimpse of the scanner. Mainly 3D scanners are used for two applications, reverse engineering and 3D inspection. First, I want to start from reverse engineering application. See, the first step is to scan the object. Imagine you have a component, you want to create a CAD model for either manufacturing or CE application. First step is to measure. In order to measure, you use a conventional equipment which you are unable to use for the measurement because part is quite complex. So use the scanner, you scan the part. Once you scan, the scanner gives you .stl file which is not directly manufacturable. You have to convert this STL file into 3D CAD model. This process is called 3D reverse engineering process. This happens in a reverse engineering software. And then after you create a CAD model, you can directly export into IGS steps and parasolid files. This is a reverse engineering workflow. So now I have a very interesting case studies that I have used with this technology. Okay. So this is the first application where you see the vintage component, they don't have a physical part or the physical part is broken or it's not available locally. So we were able to scan the object, create the scan data, create the 3D model, and then we could print the same, implement into the vehicle. This is a right application for the 3D digital manufacturing. Okay. And there's another example where same component is broken. Temporarily we have restored it, we have 3D scanned it, created a CAD model and then 3D printed the same and implemented in the vehicle. And here the customer wanted to create the ergonomic study and some kind of advanced study on the vehicle. Okay, they don't have a CAD model or they want to do some competitive study. So we were able to scan this complete vehicle interior, created a CAD model and the CAD model which they used into CAE, CMD software for further analysis. And this is a vehicle interior modification application. Say they wanted to, like recently for election vehicle they use campaign cabs, so they make a lot of modifications in the vehicle. So we were able to scan the vehicle, create the data, use the data as a reference, create the CAD model. Those CAD models they use it for the further vehicle modification. This is two-wheeler vehicle benchmarking. So like sir said, a lot of EV companies now come up. So you can bring any vehicle parts from China. We were able to scan them, create the manufacture ready CAD model. Not only manufacturing, but we can also create a CAD model which can be modified. Okay. Say for example, you might have heard a KDR, Graphics, a lot of CAD softwares. These CAD softwares are not reverse engineering software. The CAD softwares are CAD softwares. They use it to design from the scratch. We have a software called Geomagic Design X. So this software, what does? It imports the scan data, create a parametric CAD model, and this complete history, it transfers live to your CAD system, which means, let's say if you're using any graphics, without using any graphics, I can scan something, I can create a model, I can deliver the graphics file without using it because of this live transfer function. Okay, so this software, Geomagic Design X, can communicate with all the CAD system, ADR, Unigraphics, Creo, Inventor, which means it can create the history and it can transfer to your CAD system. You can have a design modification in your CAD system itself. So we can also create a CAD model for design modification. Okay, and this is another study where customer wanted to study the full range motion according to the steering wheel. Okay, so we have 3D scanned the object, created a CAD model which they used for further study and simulation. Vehicle accessory is a huge market. We get a lot of inquiries. People after the car release, people bring the car. We scan the vehicle interior exterior for other accessories fitment. This is for floor mat application. We scan the complete car floor mat, created the model, and they manufacture it. And for mudguard also. So we can scan, create a model which can manufacture. We also have a software called Exact Flat. Okay, this is another application where let's say people like nail wrapping, they make it, right. So it's very hard for them to measure to create the pattern cut. What they do, they take a paper, they put the paper into it. They take a measurement. It's a very hard process. Okay, now we have a scanner. We can scan any vehicle, create the surface like this, and there is a software called Exact Flat to create the complete pattern. Say flatten the surface. Now any CAD surface, it can flatten it. With the flat pattern you can use to cut the sticker. Okay, so directly you scan it, create a flat pattern, and then put it into the CNC machine, cut it, and paste it. This measurement time it saves. And then this is for design engine modeling to vehicle effect system. Say any of the existing system that you want to create a CAD model for further design. Let's say you want to do a new product. Okay, here they wanted to change the exhaust system. So we have 3D scanned it. The scan data we have used it for creating the system, and then they exported a IGS website parasite file for manufacturing. This is another application where they want to do FEM simulation of the racing car. So you are able to scan it and then create. This is the scan data. This is the scan data. First step. This is the regional segmentation. So like I said, the software Geomagic Designix, it has got some intelligence. It can tell you what CAD region the original design engineer would have used. Not just typical reverse engineering. It tells you, let's say, extrude, revolve, sweep, plot, all types of CAD regions. It tells you design engineer would have potentially used this feature. So you can extract those features and then create a CAD model like this. And another interesting application of the engine. Okay. So this is actually complete engine. We have 3D scanned the assembly engine and we have cut the engine. We scanned the internal surface and we have aligned the internal surface with the original scan, created the CAD model for FEM study. So not only the external surface, we can cut, we can also scan the internal surface and we can align them almost. So this is a 3D inspection application. So there is another application where, let's say, you manufacture it, you designed it, you manufacture it. You want to check the manufactured output along with the checking the CAD model. You can scan the object, import the scan data, import the CAD data, align them together, create the 3D inspection report. This is another application of 3D scanning in a quality control. Okay. So there are some applications where this is scan data, this is the CAD data, and you can align them, create the report, 3D inspection report, 2D inspection report. This is scan to scan. Let's say before and after study, or before applying the load, after applying the load, we can scan the tires before and after applying the load. We can understand how the change happens. The study you can make it in the Geomagic Control X. So this is another software where we do it for inspection. The scan data, the blue color one you see is the scan data, that is the CAD data. You can align them, create the 3D comparison map. Okay, and you see the green color within tolerance. Wherever goes out of tolerance, it shows you red color. Wherever material is less, it shows you blue color. So you can understand, okay, where to improve the tool. That kind of insight you can get it from the report. And this is a live plan. So even without 2D drawing, you have a component. You don't have a CAD model. You can scan, take a measurement like this. Heat model inspection. This is the vehicle, the entire vehicle inspection. So apart from this selling and services, we have a very unique solution, automotive benchmarking. Any kind of vehicle, 2-wheeler, 4-wheeler, we can bring to us. We have a tear down team. We can completely tear down the vehicle to each and every part. We can scan them, create a manufacturer CAD model, benchmark CAD model. We have 3 solutions here. This is the vehicle scan to CAD. We scan the vehicle in assembly condition, theoretical condition, create the CAD model for benchmarking purpose like this. And another solution, this is a vehicle occupant and architectural study without tear down. We don't have a tear down. Just we can scan the vehicle interior, exterior. Say you standard, we can take all measurements like this. We can give you complete. Okay, thank you very much.